So before we initiate the study of laser, you must know the full form of laser. It means light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. Okay, so you're amplifying light. Now with your current concept of coherence, all right, let us see what are the different kinds of emissions that take place in an atom. So when an atom is excited, well, when an atom is excited to a higher lying level by applying light on it. So for example, suppose say you have a ground state of energy E1, all right, and you have an excited state of energy E2, all right. Now, well, if you allow, say, light to fall on an atom, if light is allowed to fall on an atom in the ground state, light of frequency say h nu, this energy is absorbed by the atom and it goes to the higher lying excited state. So once it goes to the higher lying excited state, after absorbing the energy, if it comes over here, okay, this is E1, this is E2, then what happens? It will actually come down immediately after a specific time. Okay, it will come down immediately to the lower lying level, giving out an emission of frequency again h nu. Okay, so if the incident photon having energy h nu 12 excites the atom to the higher lying level, the de-exciting energy of the corresponding atom will also be h nu 12, which will actually be equal to E2 minus E1. Okay, now this kind of emission that takes place, we call this spontaneous emission. And in spontaneous emission, what happens? The photons are emitted randomly in all direction. This is what is happening in the light that is glowing in our room. Okay, all random emissions of photons take place in spontaneous emission. Okay, after the absorption of energy by an atom in the lower lying state. So atoms absorb energy, go to the higher lying state, and when they de-excite, they emit the radiation equal to the difference of the energy levels. Okay, and the emission is spontaneous. So we call this emission spontaneous emission. Okay, and takes place randomly. So this emission actually takes place randomly. It's a random emission. In all direction, so no directionality is there, in all direction. And number two is that, well, it is incoherent. It is, all emissions are incoherent. So it doesn't satisfy the conditions of coherence that we were talking of before. Okay, so what does it depend on? This type of emission will depend on the type of particle and the type of transition that is taking place, but it will be absolutely independent of outside circumstances. Okay, so this is spontaneous emission, but along with that we have another, this is spontaneous emission which is taking place. Okay, now along with spontaneous emission, we have spontaneous absorption. We have the phenomenon of spontaneous absorption. What is spontaneous absorption? So if the photon of energy h nu 12 is incident on an atom in the energy state 1, then the atom will undergo an upward transition, isn't it? So it absorbs this energy and it will undergo an upward transition like this. All right. So in the higher energy state E2, by the absorption of this incident photon, this transition due to absorption of the photon is the you can call this stimulated absorption. I won't say spontaneous absorption. This is called stimulated absorption. Okay, it is stimulated absorption. All right, that means here the atom is being stimulated by the photon and then absorption takes place. Once it is absorbed and it goes to the higher lying state, the emission that takes place is spontaneous emission. This happens spontaneously, but here you have to apply a stimuli. So if you put it in drawing again, it's the same diagram, all right, where an atom in the lower lying state, all right, it is actually receiving the photon H nu 1 2 and it is actually going to the higher lying state. So the direction is this, and well, so this is stimulated absorption. Now the important thing that we have is conceptually, which actually plays a crucial role in the making of a laser, is the stimulated emission. Now how does it differ from these two processes of spontaneous emission and stimulated absorption? Okay, so let's try to find that out. Okay, so for stimulated emission, what happens basically, you have the atoms in the higher lying levels. Okay, so you have an atom over here. Now an atom which is already over there, it can de-excite by spontaneous absorption. That means it will actually remain in this level depending on the lifetime of this level. It will remain in that level for that short lifetime and then it will come down to the ground state. But then at that time the frequency of emission might not be the same as the frequency of the corresponding incident photon. Okay, but now being in this level, suppose say a photon actually stimulates this atom of frequency, say, okay, if it stimulates the atom of frequency H nu 1 2, it stimulates this atom. Before it comes down to the lower lying state, this atom is stimulated by a photon of frequency H nu 1 2. In that case, when the atom absorbs this energy to come down to the lower lying level, that frequency will be exactly equal to the frequency of this photon. That means it will take exactly this energy, or it will take exactly this frequency to de-excite to the lower lying level. Okay, so here, well, instead of one photon, therefore, you will get two photons. That means this actually stimulates the atom. It's not that it is actually transferring its entire energy to the atom, because the atom already has that energy available due to the difference of the energy level. It just gets stimulated such that its frequency is same as the frequency of the incident photon. So instead of one photon now, which has been stimulating this atom, now you have two photons. Okay, two means one which has stimulated and the one which comes due to de-excitation, both having the same frequency, and so this actually becomes coherent because the frequencies are nearly the same. This kind of emission is called stimulated emission of radiation. Okay, stimulated emission of radiation. All right, so in this type of emission, the emitted photons have same energy, same direction. Photons have same energy, same direction and phase. Same with whom? Same with the energy, direction and phase and frequency of the incident photon, which acted as a stimulant. Remember, it did not supply its energy, it did not give away its energy. It was there, it acted as a stimulant. It's just like catalyst. Okay, so if you have two such photons, acting on two atoms, the resultant number of photons that you'll be getting is 4. Okay, two photons as stimulant and two which are already produced having the same frequency as the stimulating photons. So now a multiplication of radiation of same intensity in same direction is taking place, and this is called stimulated emission. Now will you not have spontaneous emission here? Yes, you will have. Now this spontaneous emission which you will have will not occur due to stimulation, and so this acts as, the spontaneous emission over here will act as quantum noise. The spontaneous emission acts as quantum noise in this case when lasing action is taking place. So this is lasing action. Now what is the necessary condition for lasing action? Well, the necessary condition is that the number of atoms in the excited state should be greater than the number of atoms in the ground state, and that is called population inversion. Okay, so let's stop over here. Okay.